Hi, in this video I will cover the problems from the sequences in the test 3 that is uploaded on Leah. So basically we will skip the first question. This is an old test from the previous semesters and the first question is not going to be part on your final. So in this video I'll just do the old test 3. In the first part of the video, I'll just do the sequences, okay? So that's question 2, part A, says determine whether the sequence an, which is equal to n squared times 3 minus 3n n squared times 3n minus 1 factorial over 3n plus 1 factorial is convergent or divergent. On the other hand, or on the is the same thing as asking you how much is a limit of an. Okay, so the limit of n squared, 3n minus 1 factorial over 3n plus 1 factorial as n goes to infinity. Okay, so let's think about this. What is going on with this sequence here? As n goes to infinity, the numerator goes to infinity and the denominator goes to infinity. But be careful, we cannot use here the L'Hopital's rule. Why? Because the factorials are a discrete function, okay, so we cannot just find the derivative of it. So we have to figure out another way. The first thing that comes to mind is trying to simplify this expression, and when you're dealing with factorials, you attack or you try to express the higher factorial in terms of lower factorial. So what do we have here? I have 3n plus 1 factorial is 3n plus 1 times 1 less. What is 1 less than 3n plus 1? Just 3n. And then when I'm going to stop, I can say here factorial, right? But then there is nothing obvious to be cancelled, so I go on, I move on. What is 1 less than 3n? That's 3n minus 1. And here I want to stop. Why? Because that factor of 3n minus 1 factorial is being cancelled. So what do we have now? I have limit of n squared over 3n plus 1 times 3n, and most of you can figure out right away that this is just 1 over 9, or if you cannot do it, and why n over 9? Because I have a quadratic expression in the numerator and quadratic expression in the denominator. So if you cannot see that right away, then just factor n from this factor. You're left with 3 plus 1 over n times 3n as n goes to infinity. And now n times n is n squared, cancels out with the numerator. Send n to infinity, this guy goes to 0, so 3 plus 0 is 3. 3 times 3 is 1 over 9. Okay, the next question, part B. Limit of e to the power of 2n times sine of 1 over e to the power of 2n. As n goes to infinity, the first factor goes to infinity, and the second one here goes to 0. This one here goes to 0. Why? Because this denominator goes to infinity, right? It's the same expression as this one. So a constant divided by something goes to infinity tends to 0. Sine of 0 is 0. Okay, I have infinity times 0, which is undetermined product, right? We don't know how much is that. So I'm going to prepare this for the use of the L'Hopital's rule, or MI. Okay, so what do we do here? I have 1 over e to the power of 2n. So these two expressions are the same. And of course, you can use the L'Hopital's rule here, but I've prepared you in class always to come back to the limits that we learned in Cal 1. One of them, very important, was limit of sine of theta over theta. As theta goes to 0, this ratio tends to 1, which is the same as theta over sine of theta. As theta goes to 0, this one goes to 1. Okay, so now n doesn't go to 0, but actually this, let's call it angle, here approaches to 0, and so if this expression here, it's called theta. Then I have sine of theta that goes to 0 divided by theta that goes to 0, and this limit here is 1. Okay, so we have the next question. Limit of -1 to the power of n times 2 to the power of 2n over 5 to the power of n, as n of course goes to infinity. So what do we have here? Okay, here I want you to recognize that 2 to the power of 2n is nothing else but 2 to the power of 2, the whole thing raised to power n, which can be written as -1 to the power of n of 4 to the power of n over 5 to the power of n. Or that can be written as a limit of -1 to the power of n times 4 over 5 to the power of n. Okay, so what happens now? This factor here just alternates between positive and -1. For each for each even n, we get +1. For each odd n, we get -1. Of course, n is an integer, right? Positive integer. On the other hand, this here, as n goes to infinity, goes to 0. Why? Because r to the power of n, as n goes to infinity, goes to 0 if and only if absolute value of r is less than 1. And basically with this I have answered how much is this limit, because you can put -1 in here and you'll have -4 over 5. Absolute value of -4 over 5 is equal to, absolute value of 4 over 5 is less than 1, or simply you can think about this one as positive or -1 times something very small that tends to 0, that simply is going to be 0. Of course, another way to approach this, if you want, you can say that -1 to the power of n times 4 over 5 to the power of n is less or equal to 4 over 5 to the power of n, and greater or equal to -4 over 5 to the power of n. Now if you send n to infinity, this will go to 0, and also this will go to 0 as n goes to infinity. So here you can use the squeeze theorem if you want. So by the squeeze theorem, a limit of -1 to the power of 4 over 5 to the power of n, this is n, I said 4, I'm sorry, is equal to 0. So there you go. I have given you 3 different ways how to think about it. Either just think about this fact and plug -1 in here, or just think about this fact and the fact that 4 over 5 to the power n tends to 0, 0 times positive for -1 is 0, or use the squeeze theorem. So it is up to you. How are you going to approach this? How are you going to approach this problem? Okay, now part D, it is the limit of -24n factorial over n to the power of n. Here I can pull out -24 right away outside of the limit, because it's a constant, doesn't depend on n, so it is not gonna affect the general behavior of the limit. Of course, it's going to be multiplied by -24, and that will affect it if this converges to some number. But let's see what is happening here. To some converging to some number different than 0, right? So there are a few ways how to answer this one. The easiest way is by order of growth, right? Since n to the power of n goes to infinity much faster than n factorial over n to the power of n tends to 0 as n goes to infinity. So this is -24 times 0 is equal to 0. Another way how to do this, for some students, maybe your teachers asked you to use the squeeze theorem here as well, then n factorial over n to the power of n would be 1 times 2 times 3 times 4 times n minus 2 times n minus 1 times n, and then n to the power of n is just n times n times n times n times n times n times n, and here I have n times, right? Okay, so let us express this product in a slightly, just a little bit different. That's 1 over n times 2 over n times 3 over n times n minus 1 over n times n over n. Okay, these two can be cancelled, and that's just product of some number times 1, so we can forget about this last factor. And now I just want to make sure, so this is 1 over n times 2 over n times 3 over n times 4 over n times n minus 2 over n times n minus 1 over n. And as you can see, in each case, mind that n goes to infinity, in each of these cases, right, in each factor here, each ratio is going to be less than 1. Why? Because the numerator is always less than the denominator. So this is less than 1, this one is less than 1, and then every single factor is less than 1. Right? All of these are less than 1. So if I take one number, say 1 over n, and I multiply it, so a product of numbers less than 1, it is going to be less than 1, right? Just think about a half times a third. That's definitely going to be less than 1. So if I have 1/2 times this product here that is less than 1, I will get something less than 1 over n. So one more time, 1 more over n is going to be greater than 1 over n times something less than 1. Okay then. If you follow these equation signs, so this is equal to this, equal to this, equal to this, but then less than 1 over n, we have that n factorial over n to the power of n is less than 1 over n, but it's always positive. Okay, and then send n to infinity, 1 over 10 tends to 0. So as we go to infinity by the squeeze theorem, using the squeeze theorem, n factorial over n to the power of n goes to 0 as n goes to infinity. Okay, the next problem is part E, limit of ln of e to power n plus 1 plus 3n divided by e to the power of n plus 2. N tends to infinity, as we were talking about, as we talk about sequences. So here the denominator goes to infinity, and here the numerator goes to infinity, but without avoiding some fancy stuff and relying on what we know from Cal 1, let's just factor out the highest exponent. In that case, is going to be the highest, fastest growing term to infinity. In that case, it's just going to be the exponential e to the power of n. So this is e to the power of n times e, the first term, plus 3 to the power of n. You don't really have to write this step. I'm just writing it here so that everybody's going to be on the same page what's going on, plus 2. Now I factor e to the power of n. And I do the same thing in the denominator. So as I factor e to the power of n, I'm left with 1. 1 times e to the power n is e to the power n, plus 2 over e to the power of n. And now what do we get? You cancel the common term. Okay, as you send n to infinity, a constant divided by something that goes to infinity tends to 0. And here, although I have both of them going to infinity, right? We know that a polynomial and this is the slowest growing polynomial, the linear one, divided by the exponential. This will go to 0 by order of growth. Why? Because the exponential goes to infinity much faster than any polynomial. So what are we left with? We are left with ln of e, and I expect that you know that ln of e is 1. Okay, part F, limit as n goes to infinity of n times cosine of n pi over 5 to the power of n squared plus 1. So what do we have here? Again, we have this alternating mechanism in disguise, right? So cosine of n pi is equal to -1, +1 as a sequence, right? -1, +1. If we start with n is equal to 1, cosine of pi is -1, then n becomes 2, cosine of 2 pi is 1, and so on and so on. So basically, we can write this limit as a -1, so the first term is negative to power n times n over 5n squared plus 1. And of course, the logic that follows this question is very similar to the one that we solved in part C. So you can try to do it by yourself before you watch before you watch how I solve it, times n over 5 to the power n squared plus 1, as n goes to infinity, n over 5 times n squared plus 1, sorry about that mistake. This term here goes between -1 and +1 only, alternates between those two values. On the other hand, this term, as n goes to infinity, the higher exponent in the denominator brings this ratio to 0 very fast. So I have positive or -1 times 0, that's simply equal to 0. Or of course you can use the Squeeze Theorem here also if you like. Okay, the next question is very similar. Okay, part G says a limit as n goes to infinity. Okay, you have that alternating mechanism explicitly written, -1 to power n times cosine of e to power -n over arctangent of n. So this is a busy question, right? Asks you a lot of things. So if you are a little bit confused with e to the power of -n, just write it as a fraction, 1 over e to the power, cosine of 1 over e to the power of n divided by arctangent of n. Okay, so it asks you first of all what happens to this ratio. This ratio goes to 0, cosine of 0 is 1, and then it asks you what happens to arctangent of n as n goes to infinity. Arctangent of n, this is the function, so it approaches pi over 2. Okay, so I'm going to rewrite, I'm going to use one more line here in order to make it a little bit more clear. Limit of -1 to the power of n times cosine of 1 over e to the power of n over arctangent of n as n goes to infinity. Okay, so this ratio goes to 0, cosine of 0 goes to 1, and the denominator goes to pi over 2, which means that this limit will diverge between positive or -1 times 1 over pi over 2 is 2 over pi. So as we are approaching to infinity, for each consecutive term, I'll get something that's very close to positive pi over 2, then negative pi over 2, positive pi over 2, negative pi over 2, positive pi over 2, negative pi over 2, and so on to infinity. It will not converge to one particular value. Be careful when we talk about convergent sequences. We think about one value. If the limit converges only to one number, right? It cannot converge to, you cannot say that the sequence is convergent to two values. Okay, that's not what we think by convergent sequence. So this one diverges because as we go towards infinity, we'll start flipping between positive and negative 2 over pi. Part H, a limit of 2n plus 1 over 2n to the power of 4n as n goes to infinity. Here the base goes to 1 and the exponent goes to infinity. So you can do that a long process where you're going to write this as a limit of e to the power of ln of 2n plus 1 over 2n to the power of 4n, then bring this exponent in front of ln, and so on and so on. Or have this limit in mind, n over n to the power of bn as n goes to infinity approaches to e to the power of ab. We showed this, we proved this when we learned about L'Hopital's rule, and then we have practiced it so much during the semester. So if you do on the past finals, you will see that it keeps on coming back, sometimes just like this in a question about sequences, sometimes as question about series. So it is something that you should be aware of. You should know this limit. How, question H, this limit here fits this definition? Well, first of all, I'm going to separate this as 2n over 2n plus 1 over 2n to the power of 4n as n goes to infinity. And this is 1 plus 1 over 2n, because you cancel 2n and 2n, to the power of 4n as n goes to infinity. Now if I compare this to this definition, I can see here that capital A is 1/2 and that b is equal to 4. So because we are aware of this limit, this is e to the power of 1/2 times 4, which is e squared, and you're done very, very fast. And the last question, part I, is just the use of the Squeeze Theorem Okay, sine of n is bounded between -1 and 1. Looking at the tail of ln of n is going to be positive, so if I multiply both sides by ln of n, I get negative ln of n. I multiply by 1 over ln of n, my bad, less or equal to sine of n over ln of n, less or equal to 1 over ln of n. And then we know that ln of n goes to infinity eventually, very slowly, but it does go to infinity. A constant divided by something that goes to infinity tends to 0. And literally the same thing happens here. So you just write by the Squeeze theorem. This limit here is equal to 0.